given some weird function like this with a messy or not normal exponent, how do you derive this? Well, a good trick I learned is called logarithmic differentiation, deriving with logarithms. Now, what does that mean? If you aren't familiar with the natural logarithm function, I like to sort of think of it as like taking down exponents, right? So given some function is some base a to the x. If you were to take the natural logarithm of both sides, you could rewrite it as x times the natural logarithm of the base, so a. And intuitively, this makes sense if you know what the natural logarithm means, right? In trigonometry. But now, given we know what the natural logarithm is, how do we use it in our case? Well, to sort of make it easier to derive, we can use that same logic and take down this exponent, right? So we can do the natural logarithm of both sides to get sine x to the cosine. We can rewrite this and take down our exponent to make cosine x times the natural logarithm of sine x. And now, just with any other function, we can use the product rule to derive this, right? So starting from the left side here, if you aren't familiar, the derivative of the natural logarithm function of some x is 1 over x. But now, given we're dealing with a function, yes, this would become 1 over y, or 1 over f of x, whatever you want to call it, whatever you're dealing with. But because of the chain rule, while deriving, this would be 1 over y times y prime. And now we differentiate this side as well using the product rule, just like any other function. So we can start off by let's derive cosine first. So this would be minus sine x, right? And we don't derive this yet, so we keep it as is. Plus, because we're doing the product rule, now we derive this to get, as we've shown before, sort of our 1 over x. But because of the product rule, we derived it again, so this would be 1 over the natural logarithm of sine x. And we can really just put this on the denominators to save some space. And so by the chain rule, we derive what's on the inside, which would become cosine of x. And now, our whole goal here was to find our y prime, right? We're deriving our function. So given that we have 1 over y times y prime, well, we just times both sides by y to get this out of here, right? This becomes 1. And we can isolate our y prime here. So this whole thing times y, or times our function, right? And so we're just left with this whole mess, so y times minus sine x natural logarithm of sine x plus, we can simplify this to cosine squared of x over the natural logarithm of sine x. And that's our derivative. So just to sort of sum up what we did is, so logarithmic differentiation, sorry, that's a big word, involves taking the natural logarithm of both sides and then, given our next step, we differentiated, or we derived, it's a shorter word, and then we multiplied everything to, I guess, isolate our y prime. So multiply y, we isolated what we actually wanted, which was our y prime, because we're deriving our function, right? And so that's logarithmic differentiation.